Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss factorization of algebraic expressions. You might have already learned the multiplication, addition, subtraction and division of algebraic expressions, and you must be clear about the basic algebraic identities. So if you have not revised these topics, you do revise these topics and attend the sessions of them. Okay. Just begin. Now, first of all, let's discuss the term factors. Friends, you might have already learnt in your previous classes or in your arithmetic classes what are factors. Suppose I have a number 6. So 6 is the product of 2 and 3. That means what? The 2 and 3 are factors of 6. Okay, and we can say 6 is the product of 2 and 3. Suppose we have any other number, maybe 12. 12 can be written as 4 into 3 or maybe 6 into 2. Okay, so 4 and 3 are factors of 12. Similarly, 6 and 2 are factors of 12, and 12 is product of 4 and 3. Similarly, 12 is product of 6 and 2. So this is what is arithmetic factorization. Now similarly we have to learn algebraic factorization. Okay, so what's algebraic factorization? If an algebraic expression is written as a product of numbers or algebraic expressions, then each of these numbers and expressions are called factors. Factors of the given algebraic expression. Now the algebraic expression is called the product of these factors. And this entire process of breaking up any algebraic expression into factors is called factorization. Suppose I have two algebraic expressions, say x plus y and x minus y. Now suppose I multiply both of them. So what I will be getting is, it's x plus y into x minus y. I'll be getting x square minus y square. That means x plus y and x minus y are factors of x square minus y square, and x square minus y square is product of x plus y and x minus y. And this process is known as factorization. Okay, let's discuss one or two more examples. Suppose I have x minus y, x square plus xy plus y square. The product of these two algebraic expressions will be x cube minus y cube. Now these two, that is x minus y and x square plus xy plus y square, these two are factors of x cube minus y cube. Or we can say x cube minus y cube is product of these two. Okay, so if we multiply both of them, we'll be getting x cube minus y cube, and individually both of them are factors of x cube minus y cube. Or in other words, we can say if we divide x cube minus y cube by x minus y, we will be getting the remainder as 0, or it is perfectly divisible by x minus y. Okay, so just see. That means if you divide x cube minus y cube by x minus y, you will be getting x square plus xy plus y square as quotient. Okay, and you won't be getting any remainder. Similarly, if you divide x cube minus y cube by x square plus xy plus y square, then you will be getting x minus y. That means x cube minus y cube is perfectly divisible by x square plus xy plus y square, and after division it will give x minus y as a quotient. Okay, so similarly let's take one more example. Suppose I have x4 minus y4. It can be written as x minus y, x plus y and x square plus y square. Now all of these are factors of x raised to 4 minus y raised to 4. Okay, and x raised to 4 minus y raised to 4 is the product of x minus y, x plus y, and x square plus y square. So x square minus 4 y x4 minus y4 is divisible by x minus y. It is divisible by x plus y, and it is also divisible by x square plus y square. Suppose I divide x raised to 4 minus y raised to 4 by x square plus y square. I'll be getting this as quotient. So it is x minus y and x plus y, which can be further written as x square minus y square. So if I divide x4 minus y4 by x square plus y square, I'll be getting this as quotient, and I will not be getting any remainder. Okay. Now first let's discuss the factors of a monomial. Now what is a monomial? It's a single term of an algebraic expression. Suppose I write x square y. This is a single term. Suppose I write x square y plus xy square, then there are two terms. Okay, so if there are two terms, it is known as binomial. That is the polynomial with two terms. So at the very first case, we are discussing the factors of monomial. Suppose I have an algebraic expression, for example, x square y. Okay, now what can be the factors of x square y? It's x square y and x square y, or we can say 1. All of these can be factors of x square y. That is x square y, x square y, and 1. Okay. Similarly, I take more examples. Suppose I have an algebraic expression 12x square. Now it is a combination of a number and a variable. So we can find the factors we can break this number into its factors. So what are the factors of 12? It's 1, 2, 3, 4, 6 and 12. And what are the factors of x square? These are x and x square. Okay, so we will be getting the various combinations of factors of 12x x square. So let's write some of the examples. X into 1, that is x will be a factor. I am writing over here the factors of 12x square now. Okay, so x is a factor, 2x is a factor, 3x is a factor, 4x is a factor, 6x is a factor, 12x is a factor. Similarly, x square is a factor, 2x square is a factor, 3x square is a factor, 4x square is a factor, 6x square is a factor, and 12x square is a factor. Okay, and apart from that, all these 6 numbers will also be factor. That is 1, 2, 3, 4, 6 and 12. Okay, so these many factors we are having of 12x square. That means if 12x square is divided by any of these, we'll be getting the remainder as 0. Okay. Now let's take one more example. Suppose I have to write down the factors of say 15xy. Okay. Now what are the factors of 15? It's 1, 3, 5 and 15. And what are the factors of xy? It's x, y and xy. Okay, so we can write down all the factors of 15xy, that is x, 3x, 5x and 15x. Similarly, y, 3y, 5y and 15y. Similarly, xy, 3xy, 5xy and 15xy. And along with that, 1, 3, 5 and 15 will also be factors. Okay, so these many factors we are having for 15xy. Okay. Friends, in our junior classes, we have learned common factors, greatest common factors, or we can say highest common factors. Okay, let's go for a quick recap. Suppose I have to find out the HCF of 24 and 16. So what is the first step? That I will go for prime factorization of individual numbers. So what 24 is? It's 8, that is 2 cube into 3. And what 16 is? It's 2 raised to 4. Now this 2 raised to 4 can be written as 2 cube into 2. Now we see 2 cube over here also and 2 cube over here also. And this is the highest number which is common between these two. Okay. So HCF of 24 and 16 will be 2 cube, that is 8. Okay. Similarly, we have to learn to find out the greatest common factor of a monomial. In this case, we'll be dealing with even variables. Okay. Now let's take some examples for better clarification. Suppose I have two monomials, or I can say two algebraic expressions. Say 21 a cube b7 and 35 a raised to 5 and b raised to 5, and I have to find out the HCF of these two monomials, or I can say algebraic expressions. So first of all, what I would do is I will find the HCF of numerical terms, or I can say constant. So what is HCF of 21 and 35? The first step, HCF of 21 and 35. Now HCF, the factors of 21 is 3 into 7 and 35 is 5 into 7. So the highest number which is common between two is 7. So HCF of 21 and 35 is 7. Now we have to find out the HCF of these algebraic terms. Okay. So what is the lowest power of a single variable that we have to calculate? Okay, so here we are having two variables, that is a and b. Now what is the lowest power which is there? It is a cube. And what is the lowest power of b which is there? It is b raised to 5. So a cube b raised to 5 will be HCF of a cube b7 and a raised to 5 b raised to 5. Okay, so this is the HCF of algebraic term and this is the HCF of arithmetic term, so we can say constants. So the total HCF will be 7 a cube b raised to 5. Okay, the procedure is very simple. If we do 5 to 6 examples, we'll be clear about it. Okay, let's practice some of the questions. Now let's take some examples. We have to find out the greatest common factor or highest common factor of the following polynomials. Now what is the first step? First of all, find the HCF of 2 and 12, that is the numeric terms or maybe numbers. So HCF of 2 and 12 is 2. And what is the HCF of x square and x square? Since x square is common between the two, so it will be x square. Okay, so what is the HCF of the combination? That will be 2x square. So final answer to this problem is 2x square, or we can say HCF of 2x square and 12x square is 2x square, or in other words we can say that both of them are divisible by 2x square, or we can say 2x square is the highest factor which is common between these two. Okay, let's take next example. Now in this question, let's find out the HCF. HCF of 6 and 18 is 6. Then we have to find out the lowest power of individual variable. So x cube, here it is x cube, and here it is x square. So the lowest power will be 2. So we have to write x square. Then from y and y cube, we'll choose the variable or y with lowest power, that is y. So HCF of 6x cube y and 18x square y cube will be 6x square y. So it's quite simple. Okay. Now suppose I have 3 terms. It is 7x, 21x square and 14xy square. So first of all, let's find out the HCF of 7, 21 and 14. So it's 7 into 1, it's 7 into 3, and it is 7 into 2. Okay, so HCF will be 7. Okay, now let's find out the HCF of algebraic terms. It's x, x square and xy square. So let's choose the lowest power of x, that is x only, and we don't have y in these two terms, so y cannot be the part of HCF. Okay, so HCF of algebraic terms is x and HCF of numeric terms is 7. So final HCF is 7x. Okay. Now let's find out the HCF of these 4 terms. In the very first step, we have to find out the HCF of numbers. So let me write in ascending order. It's 6, 9, 15 and 21. Now 6 is 2 into 3, 9 is 3 into 3, 15 is 3 into 5, and 21 is 3 into 7. So we have 3 common among all of them. So HCF of numbers will be 3. Now we have to find out the HCF of algebraic terms. So let's see what is the x which is carrying the lowest power, that is we see x, and if we see y, there is no y in this first term or first expression, so y cannot be part of HCF. Okay, so in all, the HCF of all these terms will be 3x. Okay, I hope you are clear. Now let's find out the HCF of these 3 terms. First of all, find out the HCF of 4, minus 12 and 18. 4, minus 12 and 18. We can neglect negative sign as it is not common among all these 3. So let's find out the HCF of 4, 12 and 18. Now 4 can be written as 2 into 2. 12 can be written as 2 into 2 into 3. And 18 can be written as 2 into 3 into 3. Now 2 is common. 2 is here, 2 is here and 2 is here. And 3 is not common since we are not seeing any 3 over here. So HCF of these 3 numbers is 2. Now what is HCF of algebraic terms? A is having lowest power as 2. So I just write it over here. It's 2 and then a square. And b is having the lowest power as 1. So it's b. So 2a square b is HCF of these 3 terms. Okay, I hope you are getting my point. Now let's see this question. We have to find out the HCF of these 3 expressions. So in the first step, let's find out the HCF of numbers. So 36 can be written as 2 into 2 into 3 into 3, that is 4 into 9. Okay, so 4 into 9 is 36, so it's 2 into 2 into 3 into 3. Similarly 54, it can be written as 2 into 27, that is 3 into 3 into 3. Okay, similarly 90, it's 2 into 5, that is 10 into 3, 30 into 3, 90. Okay, now what is common? First of all, we see 1, 2. So HCF will be 2 into, then we see 3. So it's 3. Then we see 1 more 3 as common. So it's this. That means 3 into 3, 9. 9 twos are 18. HCF of numbers will be 18. Now we have to find out the HCF of algebraic expressions. So what is the lowest power of A? It's A square. So I just write it over here. A square. Then B is having the lowest power as 0. So B raised to 0. Then C is having the lowest power as 2. So it's C square. So it is 18 C square. Okay. Now in these questions we have to find the greatest common factor of the terms. Okay. So let's begin with this. So suppose these are 3 terms and we have to find out the HCF. Now what will be the HCF of 5, 10 and 15? It will be 5. HCF of numbers will be 5. Now what will be the HCF of algebraic terms, or we can say variables? That is A square. So final HCF will be 5A square. Okay. Now in this case, what is HCF of 2, 3 and 4? Nothing is common, so we can say 1 is common, and the lowest power which x is having is there is no x in this term, so x cannot be the common factor. Similarly, z cannot be the common factor. We have common factor as y only. So HCF of these 3 terms will be y. Okay, I hope you are getting my point, and now let's learn to factorize. Now let's do some problems based on factorization. Say in the first question, we have 2 terms, 3x and 9. So first of all, we have to find out the HCF of 3x and 9. So what is the HCF of numbers? That is 3 and 9. It will be 3. HCF of terms is 3. Then we don't have x over here, so variable will not be part of HCF. So final HCF of these 2 terms is 3. Now take 3 as common from both the terms. That is HCF as common. Put a bracket. Now divide this 3x by this 3. We'll be getting x. Minus, then divide this 9 by this 3. We'll be getting 3. So this is the factorization of 3x minus 9. That means 3x minus 9 can be written as 3 into x minus 3. Okay. So it's very simple. You have to take HCF as common. Then individual terms should be divided by HCF and you will be getting your answer. Okay. And if you don't know the division of polynomials, then you must attend the session of division of polynomials for your better clarity. Okay. Now similarly in this question, we have to find out the HCF of 16 and 4. So HCF of 4 and 16 is, it's 4, and HCF of m and m square is m. So finally the complete HCF is 4m. Okay, now we can take 4m as common. Then in the next step we have to divide each term by HCF. So 16m by 4m we will be getting 4. Then 4m square by 4m will be getting m. So this is the factorization of 16m minus 4m square. That is 4m into 4 minus m. Okay. Let's take more problems. Now let's see this question. First of all, we have to find out the HCF of 20 and 15. So HCF of 15 and 20 is 5. Then we have to find out the HCF of variables. that is a raised to 12 b square, and a raised to 8 and b4. So what is the lowest power of a? That is a raised to 8, and b is having the lowest power is square. So finally the HCF of these terms is 5 a raised to 8 b square. Okay, now what we have to do? We have to take this x common, that's 5 a raised to 8 b square. Now put a bracket, divide this expression by this. So 20 by 5, 4. A raised to 12 by a raised to 8 is a raised to 4. Then b square by b square is 1. Okay. Similarly, 15 by 5 is 3. A raised to 8 by a raised to 8 is 1. And b4 by b square is b square. Okay. So isn't it very simple? This is the factorization of it. Okay. Now let's see this question. First of all, we have to find out the HCF of 20, 40 and 80. It will be 20. I'm now directly writing it over here. And HCF of x cube, x square and x will be x. So we take 20x as common. Okay. Now 20x cube, if it is divided by 20x, we'll be getting x square, then minus 40 by 20 is 2, and x square by x is x, then plus 80 by 20 is 4, and x by x is 1. So this is the factorization of 20x cube minus 40x square plus 80x. Okay. Friends, we will be taking more problems of factorization in our next session. Till then, do revise this basic session of factorization, and you must attend the session of polynomial division, and you should be clear about the basics of HCF. Okay. So see you in the next session. Bye bye.